Hello, everyone. Thank you for joining us. We'll get started here in just a minute. Before we do, I'd like to give you a second to go ahead and test out your chat function. Let us know where you're tuning in from. I myself am tuning in from Portland, Oregon. Hello, everyone. It looks like we've got New York, Las Vegas, Indiana, Ohio, Toronto, Denver, Miami. Welcome, everyone. Welcome, welcome. UK, welcome. Canada, Montreal. Hello, everyone. Awesome. And with that, we'll get started. My name is Kara, and I will be your host as we discuss today's topic, scaling cloud remediation from probabilistic AI to deterministic execution, brought to you by Gumbach and hosted by VIB. Please take a moment to locate the Q&A button in your window. Use this box to ask questions. We'll do our best to answer all questions, and for those we don't get to, we'll follow up with afterwards. And again, please feel free to utilize that chat box as we go through today's presentation. And now, without further ado, I'd like to introduce our speaker, Matt Sweeney.
Thanks, Kara. Appreciate it. All right. Hi, folks. I'm Matt Sweeney. I'm the co-founder and CTO at Gombach AI. And today, as mentioned here, we'll be talking about really how we turn probabilistic AI execution into more deterministic, grounded execution and results. And along the way here, we'll have some participation with polls, which be encouraged to or interested to see everybody's input. And just as a high level, what do we want to do today? I think there's an evolving state of things as far as what it costs to generate code versus what it costs to review it, maintain it, govern it. So really, we want to dig into that and expose what's going on there right now in the current state of affairs with generative AI and with maintaining your platforms, your code, your applications in the enterprise, and to be able to leave with some concrete examples for, okay, what's an approach to kind of managing the code that I have in my enterprise to manage the evolving collaboration and how that works within teams as AI evolves and we have to adapt to evolving expectations around how is code generated, how is it reviewed, how is it maintained, how is it governed, how do we secure it, and then also with some free tools and guidance on, okay, maybe there's some ways that can help alleviate some of the pain around this. So we'll walk through here kind of an intro section around talking about the topic, talking about some approaches here, and then really dig into some concrete examples of how we make AI deterministic, and then conclude with some follow-up examples and homework if folks are interested. Just a real quick bit about myself. As I mentioned, I'm CTO and co-founder at Gombach. Previously led the engineering team for the Mandiant security validation, breach and attack simulation capability, as well as the product owner and architect for the FortiSASE solution and uh, opaque networks running that effort before that. Um, all right, feel free to reach out and connect with me on LinkedIn. Always happy to meet new folks. All right, so we'll start in with our first poll just to get a sense of kind of where people are in their current journey with AI and what your experience has been as far as whether use of generative AI has been successful, and if it didn't meet expectations or did, why not? I think Carol will go ahead and launch this poll here. First question, where do your AI-focused platform initiatives stand? We'll give folks just a little bit here to respond, and then we will share the results. And all of this is, anonymized here as far as the results are concerned. So we'll just take a look at where everybody sits. I know even for us at Gombach building AI-driven solutions, things have been evolving and changing over the past months, which we'll get into a little bit here. right. And now here we have the results published here. So getting a look at where people are. So about a quarter of folks, 27% are already in it. Things immediately coming up next using AI, 10%, soon 20%, next 3 to 6 months. This year, another 28%, and sometime, hopefully, 18%. And I think that's illustrative, probably, of how things have been evolving overall with um, AI adoption in general, is that for some it's been immediate and fast and furious. Others are trying to figure out how to engage and what's coming. And this is an ever evolving, kind of fast changing field. So looking at how people responded to the next, have your recent projects with generative AI been successful? Yes, 10% met all expectations. That's great. Would love to connect with those folks and see what they learned. Partially met 80%, and then no 13%. And I would say actually that's we've run kind of some similar kind of polls in the past, and that has changed. I think the no didn't meet used to be larger, and the yes partially met was smaller. So I think things are shifting in that direction, which is interesting. And if they didn't meet expectations, why? So then, as far as the spread here, I think short, meeting, core metrics. That's an interesting one. That's kind of increased as well over time there. The over budget and missed deadlines. It's kind of, th things happen in the course of software development, um, but I think the core metrics part is an interesting one because that really gets to what are we trying to achieve with AI and how are we measuring the outcome, which is really the most important thing. How do we establish those KPIs and how do we ground our results? All right. Well, thank you for engaging and sharing there. I think that's interesting, and I'll kind of key in on that as we go forward there. All right. So, um, let's talk a little bit about AI-driven productivity. So, I think, based on what folks shared here, there is a drive to accelerate results with AI, but there's a lot of questions that still surround it as far as how do I take the practices that I've been engaged with around engineering, collaboration, uh, establishing governance around, security, compliance, other controls, just engineering best practices. How do I implement those in the world of AI? And I think there's a kind of disconnect as far as the throughput versus stability of AI. So we can definitely generate code faster. We can deploy um, and people attempt to deploy more frequently, but then there's an increased change failure rate. And we've seen this even in cloud services where whether it's Amazon, Microsoft, things go down because there was a big push for AI-driven engineering practices and code reviews. And then turns out people can't really handle the volume of code review that's necessary to pay attention to all the details of what's being changed when we increase that severity, which leads to that stat that, that increase in AI adoption actually has been linked to, 7% or more decrease in delivery stability. So there is a trade-off there that people right now seem to be accepting to some degree, but are really just dealing with and having to, explain, okay, why is this happening? Um, there's also this reviewer's dilemma of, okay, my AI generated code increases, and now I spend my time reviewing the code instead of writing it. So I didn't really trade, what there's a trade-off there that um, basically in overall execution where I'm focusing more on debugging, being able to analyze what maybe the AI created or what my teammates created with AI and having to sift through that and then cycle that through, go through another revision, refine, rinse, lather, repeat. And then there's also just general, I think, trust issues with AI, which have been changing over the past months, honestly, from what I've seen, where there's, 6 months ago, um, you know, you might not have seen people trusting maybe in half the cases the code produced by AI, and with the updates with the most recent generative models, whether it's GPT 5.5 or Google Gemini Pro 3.1 or Claude Sonnet 4.6, 4.7, and Opus, um, the output there has been uh, steadily increasing in quality. And so the question becomes, all right, now do I trust this in my day-to-day operations, or do I need just more of it in order to analyze the code and shape my engineering practice around it? And I think this is, one of the big things. If you didn't catch in the news, the recent, in the past month here, announcement of Project Glasswing and the Mythos model from Anthropic, it's really good. And this just highlights really what generative AI is good at, which is finding problems, being able to navigate its way through these different scenarios in code, and to be able to find ways to break it. Um, so I think this is something that um, it's even the creators of the model are saying this is not something that can be in everyone's hands. This is something that needs to be treated carefully, and we're going to release it with that care. And I think this is the future that we're dealing with, is how do we actually ground or both appropriately handle AI results and understand that there's an asymmetry that's happening between the use of AI for whether it's cyber attack versus defense, whether it's for engineering productivity versus governance and quality of the output and being able to comply with certain standards. These things are going to be in attention here. So what we'll talk about in a little bit more detail here now is, all right, if we have a model like Mythos that's great at breaking things, finding ways to create new zero-day vulnerabilities, or patch together different chains of execution in order to find methods of attack, how do I get fixes in a more concrete way in my code in general? How do I ground my results? And this is really a pattern that we've implemented here and used at Gambach. And it involves, first step, giving specifications that are concrete and grounding to an agent. Um, the other is testing. And the key piece in that is having tools that make the outcome you're looking for actually testable. So you're keeping in mind that I need a way of ensuring that I can express what the goal is. Say if the goal is fixing my code, I have a way of expressing that that's deterministic. And I have means of testing that change that are also deterministic. So those are the things, those deterministic changes are what ground my result and give the agent the feedback that it needs in order to be effective. And so this is where the memorize step comes in, saying, okay, if I have rules, if I have queries, means of expressing what is being done in my code that I can store and then share with others, I have a means of creating a playbook, and then I have a way to attach it. The sharing part is not only being able to have a system that can share this memory, but also be able to anchor it to broader policies, categories of compliance, security, best practices, so that I can actually govern what's going on and get a survey across all of the code that's being produced to understand what is the quality of it, where do these changes apply, and how can I make sure that it's consistent across, these policies are implemented consistently across my code base. So just a way of kind of visualizing this through a specific example. So the grounding step, like we're talking about, converting documentation and best practices into concrete implementation recommendations. So what I'll walk through here is a very small and specific example of that. But I think on the whole, this is the challenge that enterprises face, which is how do I take knowledge of what is good and things that I know should be done and translate those into action? So being able to take certain documentation, whether it's CIS best practices, whether it's OWASP, ASVS analysis of the security of an application. I want to take that and apply it to my code and contextualize it so that I can get things fixed that make it comply with those standards. Um, the second step here of being able to test, so being able to create well-formed tests and relevant scenarios, this is something too where I can fix in isolation 1,000 times in my enterprise. But more often than not, those problems that exist in software are repetitive, are things that a team really needs to share. And this is the challenge of our human experience with AI, which is, okay, I used to go ask somebody, hey, what'd you do to fix this over here? Or how do I remember to do this? And people are looking at sharing prompts or creating wiki spaces or internal code repositories with shared prompts or registering them through an API. All of these are ways that as humans are trying to figure out how do I take the knowledge that we have about what's the right way to do something and to share it with someone else. And I think this in this approach, we're basically codifying that, saying, okay, we're going to take and start with a prompt, but then use tools like um, Open Remediation Language, which I'll get into in a minute, which let us express a set of rules, a playbook for execution, and being able to memorize that change and then apply it, and then aligning it with governance and policy frameworks so that I can understand, okay, that change needs to be implemented because it aligns with this policy. It has this level of risk. There's these kinds of impacts that are present in the application of that change. And then that gives me context as, a human to understand, should I actually make that change? So just a more specific example here, say I want to enforce standard storage classes and boundaries for AWS and Terraform deployments. And specifically, I want to have a default block storage volume size and class that's used across my initial deployments. And I want to cap the size of those volumes to make sure they're initially not created too large. So this is really a cost management policy. I need to create certain tests along the way to make sure that I don't just blindly apply this. I don't want to recreate existing volumes. I don't want to only do this for root volumes. I also want to do this for attached disk volumes. I want to make sure that the parameters, for configuring these volumes are appropriately specified. And I might want to even use some tagging annotation for volumes that should be in a high performance category. So I have certain, specific implementation that I want to consistently enforce, but I need to test it. And then I need to effectively memorize how do I apply that set of changes in the right way every time I might use a particular type of resource like this disk volume. And then as far as the severity, risk, and impact, in this case, and this comes from an actual example we have that, in our rule system at Gombach, but being able to understand, okay, the risk of this change relatively low because it's applying to newly created items, um, and the impact of limiting the size. There's this doesn't necessarily recreate the disk. It doesn't do destructive things. This is really, but the severity is higher because I could be expanding my cost quite a bit by not implementing something that prevents a terabyte disk in high IOPS category from being created. One example. But I think so now with that kind of concept in place around all right, I have the this grounding, the tests, memorizing, governing. There's really a challenge that exists with um, in a world where I can generate code very freely and maybe even generate reviews on code and push it very quickly, but I can then generate problems in production also just as quickly. And on the both governance and security side of things, there are now tools that enable you to convert natural language into, say, OPA policies or HashiCorp Sentinel policies, things of that nature, or other kinds of governance and control on the quality of applications and infrastructure. But then there's no, so I can throw up gates. I can create code and I can throw up gates and stack those, the bricks for that gate wall, but I don't have any key to get in there. And that's really where, this approach kind of opens the door, so to speak, because now I can take something that was previously a blocking item, like a Sentinel policy, and convert that into a plan to unlock the gate. So that every time that I encounter this in the code and find an issue, I actually have a means of describing this needs to be fixed. This here is the fix, and I can share that with everyone across the whole enterprise. And this is what some of our customers are doing. So the HashiCorp Sentinel policies, as I mentioned, they're a great way to prevent mistakes from happening in production deployments. And the uh, the thing is, okay, if I want to make use of these, um, there's often objections that teams have around, well, before you throw up a lot of policies, let's make sure they're not going to prevent us from deploying in production. They're too expensive. It takes me too much time to figure out how to fix these things. They're sometimes not relevant, whatever the argument might be. We've heard a lot of them along the way that really the problem is the effort it takes to actually align with the policy. And so being able to convert that policy into automated fixes is something that we'll demonstrate here. So I'm going to share something different here. Up the right. Whoop, that's not the right one. Sorry. There we go. Okay. So what I've done here, I'm set up in Claude Code with the Gambach community skills that convert Sentinel policies to ORL rules, and I'm going to go ahead and run this. Now, what's happening right now is, this policy, Terraform, HashiCorp have provided several hundred policies that are available for Sentinel to the public. People often use them for Terraform deployment, configuration protection, and they're usually used as a gate to make sure that no mistakes are made or that organizational policies are complied with when pushing code into production here. But what this policy does, and I'll review it while this generates here. Well, it shouldn't take that long. What I'll share is this here. So here's our GitHub. This is what the policy does, is it looks to prevent deletion protection of RDS instances so that, say, I have a production database, I don't want someone to be able to go in and accidentally delete the whole thing. This makes sense. Um, and what this rule does kind of by default is just provide a warning saying, okay, if deletion protection is not enabled, then make sure that it is and produce a violation otherwise. Relatively straightforward rule. Now, if I go back to my Claude here, so now it's already done the analysis on the code and said, okay, this is what this new policy does, and I have a plan to convert this and create a fix for it. So the AWS DB instance will have deletion protection enabled if it's absent, and it's equivalent to the Sentinel policy. And it even tells me about the limitations. So yeah, go ahead and build this. And what the system is doing while this is running here, I can talk a little bit about what ORL is and what it does. So let me go back to presentation here. Sorry, I just opened the screen. That cooks. Sorry, one moment. There we go. So now here with the uh, talking about ORL, the Open Remediation Language. So what is this? Why is this? Why did we create this? It's a simple YAML structure that lets us define queries in syntax tree format, AST format against code. And the purpose of it is to provide the ability to collect information about the code environment, to audit that environment, and then to provide changes to the code. So remediations in the form of changes, replacements, insertions, new files, and being able to uh, basically describe in a single rule or sets of rules that are either uh, sequence, mutually exclusive. It can handle basically this rule set definition to be able to describe this is a sequence of steps that must be executed in order to achieve an outcome. And it is built on this tree sitter S expression language, which lets us describe very exact queries in the code, the exact spot where something occurs, so that we can pinpoint where code should be changed based on an audit, and then collect all of the variables, the information that's relevant, the locations in the code, and the spots that should be fixed, and then provide a correction. So that set of changes for the correction is basically what we're describing right now as this rule generates, and I'll be able to walk through that in just a moment while it's finishing cooking here. But the general concept is that you have a way of describing what this rule looks like, and we'll take a look at the actual rule in a second. That was translating this kind of high level policy item. So being able to take very either prescriptive kind of you must do this, or this is how something works, or just a description of, hey, I have this goal that I need to achieve. How can I go about doing it? And here we go. Let's go back and view the results. All right, so we have a result here, and we can see kind of what happened along the way, just to illustrate the concept here. So after we said yes, there are a few things that our agent skills did here. And if you're not familiar with agent skills or the open agent skills standard, um, you can search for that, just the open agent skills. It's definitely worth your time to understand that in more detail. And won't go into it too much right now, but this is how we're able to effectively sit on top of systems like Claude Code and Gemini and Codex and be able to provide what we do at Gombach with specific skills that let it say, okay, I understand how to convert a Sentinel policy to this open remediation language format and to provide fixes that are very deterministic. The outcome here is that, all right, I took a look at, ensure this AWS database deletion protection is created, and I have a bunch of test cases that were created as a result. So the system said, all right, we have to figure out how we can ensure that this is a well-rounded kind of memory that I'm creating here for how I can describe what different storage allocation and configuration, in this case, the deletion protection is the example. So pretty straightforward. If it's present, if it's correct, if it's not, if it doesn't exist, great, I have those cases. Now let me go and explore and apply the changes here. So now it's went through and actually was able to walk the code. So this ORL walk actually goes in and does a syntax tree walk of the code to understand what are the changes to be made. And so all of these tools anchor the machine's behavior, the agent's behavior, so that we can get to very specific test outcomes and get the correct queries on the code itself. So rather than just viewing the code as a block of text, this is something that we have support for, say, 38 languages in this, through RL, so that we can walk nearly any code that it might come across, and even handle situations where different types of code are combined together because it's loading incrementally that code and walk through it. So we have the kind of different patterns that we need for different test cases, which have been outlined. And then we also created this deletion protection rule in ORL, which if I hit Control O here, will be more fully expanded. Where did it go? Oh, I'll look at that specific file so you can see it. Here we go. It's not letting me expand. Sorry about that. All right. In any case, I will open up this file path. And here we are. So this is the rule set that was created for ensuring the database has deletion protection enabled. We get a description of what the rule is doing, understand which cloud resources it applies to, which cloud provider, what the correlation to Sentinel policy is. We keep track of different policy references, and we anchor it to any existing policy frameworks we have so that you can govern the change. So if you just want to enable a policy for deletion protection in general across all your resources, it's easy to do that beyond the specific rule. And then each of these particular rules says, okay, make sure I set this value to true when it's false, and then also find the particular location and the code that this doesn't exist and insert it if it is not there. So pretty straightforward from that perspective, but it did, basically used AI to ground all of this work and then make it repeatable. Right. And then when we're all done here, what the agent is asking if we want to do is, do we want to save this? So now I have the ability to save it to my account. Um, so that's kind of the quick and dirty of creating that rule. And if I go back to the presentation here. All right. So now, as far as a bit more of all right, what does this ORL solution give us? There's several gaps in LLM capability right now, which include kind of the lack of structural awareness of the code, sensitivity to different kinds of formatting, um, the size of the context window. So those sizes have been increasing, but what you put into it really matters. And being able to see examples of what's correct versus what's not, and being able to establish that is really important. And then kind of identity and regression risk. So what if I tell the machine to do the same thing a second time? How am I going to know if those results are going to be applied consistently? So in the case of you know, cost as well, if I am able to capture these memories, I don't need to ask the AI to do this every single time. I have a way of converting something that's known good policy into fixes across my code in different languages. And so how does, something like ORL address these issues? Well, we can parse the code for all these different languages and not just handle it as, groups of words, being able to uh, have basically the syntax and formatting handled because we're doing syntax tree based searches on the code, and to be able to collect additional information that's relevant to fill in the blanks so that we can actually more fully automate the application of these fixes. All right. At this point, be great to kick up another poll here around the reality of vibe coding. So, as far as the different questions and topics here, really curious. All right, how much are you using, trusting, adopting generative AI for coding in your day to day? I think this is another one of those things that's definitely changing as time marches on here in the software engineering bench. AI systems get better with it. It's another few seconds here to respond. All right. So generative AI coding, how much time do you spend? 10 plus hours for 10% of the people, 5 to 10 hours for about 20, and 1 to 5 for 30. And then for the remaining 42% less than an hour or none at all. So I think um, I think the next question kind of illustrates, all right, does it generate errors or generates errors less than 20% of the time? So it's hitting the 80-20. I think that's interesting because that was not true even 2 months ago. So I think things have changed pretty significantly in that period of time. And then how often do you still write your own code? 3%, one person said never. I have had other folks that I speak with at different companies, coworkers from the past, say, yeah, in the past month, I stopped writing code. I write specs. Um, so that's new, but slowly appearing. Um, and then, more commonly, uh, we're still writing code. So 75% of people still 2+ days of the week or every day writing code. So I think this is helpful to know too, as far as what people's experience is. All right. I think that illustrates the reality of enterprise code bases too. When there's new code being written, things are um, you know not as complex, not the existing tech debt that you have to deal with, not the existing system integrations, all these other things. It's a lot easier to just generate things from scratch. when you're dealing with complex enterprise systems that already exist and have to be updated, maintained, added onto, then the reality is that we want a more consistent way of interacting with them and to be able to ground the results in our own experiences and understanding of how the system should work. All right. Um, so at this point, I want to take a look at applying this. So now I'm going to share back to the terminal here. And take a look at applying effects. So use the let me all right. So we're going to have it take a look using the rule we just created. Go ahead and generate some fixes. And what's happening here that's slightly different than if we were just to ask the agent to fix things itself is that the implementation here is being driven by this memory that we created for how the fix should be applied. And it's taking a look at things and saying, okay, I found some spots. I did a dry run and I found a place that this needs to be fixed. So instead of having to do a lot of deep analysis of the code base, I'm basically using AI to analyze the code and see where this rule applies. And I can also do this instantaneously by running some ORL commands, but in an interactive way, I also use far, far fewer tokens because it's effectively able to execute a dry run using this ORL rule and generate a fix. And I can say, yep, yeah, go ahead and do that. So just a brief illustration of what can be done to uh, ground AI more deterministically and to be able to apply it to code. Um, right. Let me go back here and think. Um, that was generally the overview of the product or of the technique there. Any questions? Right. It's like in Shida Sharma. Looking at operating here, Kara, should I hit allow to talk here? Or do we want to get things via text?
Hi, Matt. The questions would come in the Q&A box.
Okay.
It looks like we're all clear there.
Okay. So it looks like Anchita has their hand raised. So maybe I guess Anchita, if you can put a question in the Q&A. And while you do that, give an illustration of what this looks like, kind of applied a bit more broadly. This a bit. So this is applied to that whole repository there of Dolphin Scheduler. Kalmbach found 32 fixes, and we have a fix reviewer here where I can actually look at all the different changes, why they are relevant in the code that was just scanned, and what can be done to fix them. And I can even cherry pick and say, okay, um, what are the particular changes I want to put in place here? And then generate a preview of that. So now I get to see all these particular changes in context, all deterministically generated, and all applied with appropriate spacing changes, all of that sort of thing. And I can go ahead and keep these changes and apply them to the code, or I can revert back. But this is a way to get kind of fully governed code changes applied to this code base and enable security, compliance, cost optimization, all that sort of stuff. Right. I guess no questions in Q&A. All right. Well, thank you very much, folks, for your participation in all the polls and everything. And feel free to reach out if you have any further questions. Always happy to chat.
All right. And with that, we will go ahead and close out. Thank you everyone for attending our webinar today. We hope you enjoyed it as much as we did. If you registered through VIB with your business email and have any questions, please contact webinars@vib.tech. Thank you again and have a great day, everyone.